Hi and hello everyone, welcome to my channel. So in this video we are going to discuss about regarding a DC biasing, then load line, then operating point. So what is in by DC biasing? What is in by load line? What is in by operating point? So for faithful amplification or high current amplification, mostly we are used for common emitter configuration only. For high current amplification, mostly we are used for common emitter configuration. So for faithful amplification also we need perfect output without any disturbance. We need to get perfect output without any disturbance. Perfect output, that means no clipping in output section, no clipping in output section. That's what we are going to learn. Okay, for examples. So in the DC biasing load line and operating points, there are in two different ways possible to identify. The one is from input section, another one is from output section. So from the input section, just I am going to draw the DC load line. From the input section, just I am going to draw the DC load line. So for examples, I am going to take one DC load line. So already you know the input section, the input current is IB in microamps, and then VBE, base emitter voltage in volts. Okay, so everyone knows from the input section we are going to take curve like this. Okay, like this. So this is called VCE. So VCE is going to decide the operating point of the particular transistors. So from this I'm going to take 2-point level, like point 1 and point 2. Okay, in the point 1, the deciding first point should be like ICQ. Like from here I'm going to take IBEQ. From here I'm going to take VBEQ. So for IBEQ I'm going to take 2.1. Starting point is 0. Another one is VBB by RB. So here like starting point is 0. So like this. So 0, comma VBB by RB. Okay, from here, so this is the value VBB comma 0. So here VBB comma 0. So from here like IB equal to 0, VBE equal to VBB. The same thing here, VB equal to 0 and IB equal to VBB by RB. So from these two we are going to draw the operating point. So this is called it as Q point or operating point or stability factor point. So I am planning to draw like one operating point. So this point is like here, it will come like from here to here. I'm going to draw this. Sorry for this. I am going to draw this operating point like this. So from this they are getting one operating point. If this slope is based on that, slope. This slope is based on that minus 1 by RB. If RB is increased, the slope also going to decrease. Now I am going to increase the RB. I am going to take another output like operating point also, like this will come. So another operating point also like this will come. So this operating point is called it as like Q1. So this operating point is called it as Q2. So this distance going to vary. So this what we are going to take from the input section. So already we know the input section equation is VBB minus IBRB minus VBE equal to 0. So this is for y axis, this is for x axis. So from this we are going to analyze the output operating point from the input section. The same thing I am going to take from the output layer, output section. From the same things I am going to take from the output section. So from the output section, I think this color is not good. I'm going to change the color, I think medium point. This output section, just I am going to redraw the output waveform from the common emitter configuration based. So everyone knows output is IC in milliamps and then VC in volt. So finally, so these all are called it as IBQ. So this area is called it as saturation region. This area is called it as cutoff region. Then I am going to analyze one operating point. I am going to analyze one operating point is here. I am going to use another operating point is here. Okay. From this operating point, the same thing I am going to take slope also. Slope equal to minus 1 by RC. If RC is increased, our load line will going to change. Load line also will change. If RC value also decrease, load line also will going to change. So here this is the 0 value. So 0 comma VCC by RC I am going to use here. From here I am going to use VCC comma 0 2 point. That means this is for point 1, this is for point 2. From this I am going to redraw. I am going to use some DC load line like this. From this I am going to draw another load line like this. From here also possible to draw another load line based on that RC value. We are going to get different load line. Okay, so but we are going to solve ICEQ and here is call it as VCEQ. So from this there are 3 set of cases are available. So that means if the output is clipping or not based on the input. Okay, if the output is clipping or not based on the input, we are going to take. So this is called it as load level of the output. So in the point operating point here we will get perfect Q point. So from here there is no clipping going to happen. From here, from this point means we are going to get some clipping. This area. The same thing here also we are going to take some clipping. This area going to clip.